Hello friends, we are studying complex number and today I'll be telling you how to find the square root of a complex number. So let's begin. Square root of a complex number. So I'll be telling you two methods. One is the normal algebraic method, okay, and the other is using the formula. Okay, so one is the algebraic method and second is using direct formula. So the you might be thinking, why then I am telling you the algebraic method if we have a direct formula. The reason is that uh, see, algebra helps you to uh, have a better understanding of how mathematics work, and it also opens up your uh, uh, your speed. It increases your speed and you have a better sense of how to manipulate the variables. Okay, so if you are aiming for a competition, I would recommend you to always uh, give a lot of stress on proofs. Okay, where you have to prove a certain thing, or always use methods that are a little longer. Okay, so that because it stimulates your mind. Okay, so algebra is a very good way to improve your speed, your ability to play with variables, manipulate variables, and ultimately that is going to help you a lot in the competition. Direct formulas are also useful if you want to save your time, but it will not that it will not give you a long-term benefit. Okay, so I recommend uh, to give a lot of stress on algebraic method. So let's start with the algebraic method. Algebraic method. So suppose I have a complex number. Let us say, take an example, 8 minus 6i. I have this complex number and I want to find the square root of this complex number. So what to do? So what I'll do is I'll assume that the square root is z equal to x plus iy. So I am assuming that the square root of 8 minus 6i is z, which is x plus iy. If z is the square root of this complex number, then z square will be equal to this complex number. Okay, if suppose we have 4, the square root of 4 is 2, so the square of 2 will be 4. Similarly, if z is the square root, then z square is equal to 8 minus 6i, and z I have taken as x plus iy. So let me put here x plus iy whole square is equal to 8 minus 6i. Let us square left hand side. So x plus iy square is nothing but x plus iy into x plus iy. So let us split it, x into x plus iy plus iy into x plus iy. This will be x square. You solve it, I know the result, so I'll write the result directly. X square minus y square plus 2xy into I. This is equal to 8 minus 6i. Now remember that in a complex number, just like vectors, you have to compare the real part with the real part and the imaginary part with the imaginary part. In vectors, suppose there is vector in the form of ijk, then you if you have a left hand side and right hand side equality, you compare the I component of I on one side with the component of I on the other side. Similarly, you do it with j and k. So same is with complex number. So comparing, we get x square minus y square is equal to 8. Okay, and 2xy is equal to minus 6, or xy is equal to minus 3. So these are the two equations that we have got. X square minus y square is equal to 8, xy is equal to minus 3. Okay, either you can solve it from here by substituting x in terms of y, Or there is another easy method. Remember I told you that mod of z to the power n is equal to mod z whole to the power n. And if you see, we have a complex number z square here. So if I take mod of this z square, this will be nothing but mod of z whole square. Okay. Now mod of z square is nothing but 8 minus 6i mod, because z square is 8 minus 6i. So mod of 8 minus 6i is equal to mod z. Z I have taken as x plus iy. So modulus of x plus iy will be nothing but under root of x square plus y square. This is mod z and its square. Okay. So mod of 8 minus 6i will be under root 8 square plus 6 square is equal to x square plus y square. So what we get, x square plus y square is equal to 100. Sorry, 10. 8 square is 64, 6 square is 36, so 100 under root of 100 is 10. What is the use of this thing? It simplifies dramatically. We know that x square minus y square is equal to, what was it? X square minus y is equal to 8. So let me put here x square minus y square is equal to 8 and x square plus y square equal to 10. Solving simultaneously, add the two equation, we'll get 2x square is equal to 16, x square is equal to 18, 2x square is equal to 18, x square is equal to 9, so x is equal to plus minus 3. Okay, and what was the second information that we had? xy is equal to minus 3. So if x is equal to 3, then y is equal to minus 1, and when x is equal to minus 3, y is equal to plus 1. You can use x square plus y square is equal to 10 also. We have x, we can find y, but remember that we cannot take plus 3 with plus 1, because x into y has to be minus 3. We have to use all the three sets of equation. The final answer has to be consistent with all the three equations. So just using two equations, you might get an answer that does not satisfy this equation. So it's better to include this equation here only. X is equal to plus minus 3. So what we get finally, the roots are x plus iy. So 3 minus I, and the other root is minus 3 plus I. So I can combine it like this, plus minus 3 minus I. These are the square root, or square root of 8 minus 6i is nothing but plus minus 3 minus I. Okay, so this is the long method. We can take another example. Find the square root of, let us say, minus 1. I want to find the square root of minus 1. So I'll assume z is equal to x plus iy is the square root. So this square, z square, will be equal to minus 1. Expanding, we'll get x square plus y square minus x square minus y square plus 2xyi is equal to minus 1. Okay, so x square minus y square is equal to minus 1, the real part, and the imaginary part is 0. So xy is equal to 0. Again, using mod of z square is equal to mod z square, we'll get x square plus y square is equal to 1, and x square minus y square is equal to minus 1. Using these together, we get 2x square is equal to 0, or x is equal to 0. Okay, x is equal to 0. The other information that we have is y square, x square plus y square is equal to 1. X is 0, so y square is equal to 1, so y is equal to plus minus 1. So what do we get finally? X plus iy. So 0 plus I and